Hello guys, this is CodeNCode and this is a video editorial for the problem Partition Equal Subset Sum taken from Leetcode. The problem is from dynamic programming category. So the problem is we are given a non-empty array containing only positive integers. We have to find whether there exists a partition of this array into two subsets such that the sum of elements in both subsets are equal. So basically you have to divide the array into two disjoint subsets. Disjoint means each element must belong to at most one of the, in fact each element must belong to exactly one of the two subsets and their sum must be equal. This is an example. So if we only have to return true or false, so in this example, as you can see, there are four elements 5, 11, 5 and 1. So we can partition this array into two subsets, one containing only 11 and another containing 5, 5 and 1. So the two subset would be the sum of each subset would be 11. So since we are able to partition the array in such a way that the sum of both the subsets are equal, so we would return true. In the second example, as we can see, there are four elements again, but there is no way to divide or partition the whole array into two subsets with equal sum. So that is why we would return false. So this is the problem. So the problem is basically a standard subset sum problem from dynamic programming. So to solve this problem, what we would do, all we have to do is whether there exists a subset whose sum is equals to s by 2, where s is the total sum of the array, of course. So if you haven't seen my subset sum, or if you do not know how to find subset sum problem using dynamic programming, how to solve that problem, just go and watch that lecture first. The lecture is present in my dynamic programming series part 1. So what we would do, we would see whether there exists a subset, whether exists a subset whose sum is equals to s by 2, where s is the total sum of the array elements. We would use dynamic programming to solve this problem. Reason, the constraints allow us for that. So we see there are at most 200 elements in the array and each element won't be more than 100. The value of each element won't be more than 100. So the constraints allow us to go for the dynamic programming subset sum approach. Now the first thing we would need is, let me just increase the font size. Yeah, first thing we would need the size of the array, then sum, and then each element in the array sum plus equals element. So if the total sum is odd, there is no way to divide it into two equal parts. So if sum is odd, then of course we would return false, because there is no way to divide the whole array into two equal parts. Otherwise we would take an array, bool or int array, doesn't matter, dp. If you know from the subset sum problem, the dimensions are n. Since I work on one base index system, that is why n plus 1, and then m plus 1. M means sum by 2, because we want to know where we want to calculate this for half of the total sum. So what we do, we initialize dp of 0, 0 to be 1, which means if there are 0 elements and the total sum I want is 0, so it is always possible. I have explained this subset sum problem already, so I won't be going into much details. So for the rest, in fact, just let me take m as half of the sum, m, and let initialize m to be half of the sum, otherwise I have to reference m again and again, it doesn't matter, just for this. So for each column of the 0th row, I'm going to initialize with 0, while 0 0 would be 1, the rest would be 0, because you know, if you don't have any element, then you can't make positive sum. So for each row from 1 to n, we would fill the dp array. So for each row we would run a loop from column j to m, and this value would be true. dp of ij would be true if, true means 1 if two conditions are satisfied. First, dp of I minus 1 j is equals to 1, or first what we have to do, just let's take element is equals to ar of I minus 1, because of course the vector index system is from 0, so when I want the first element, I need to take it from I minus 1. So this is the element, and for each column from 0 to element minus 1, we would simply copy the value from the previous row. So for each j less than element, what we would do, dp of ij is equals to dp of I minus 1 j. What we are doing, we are simply copying the value from the previous row till j is less than element. Otherwise we would start from j is equals to current element is less than equals to m, j plus plus, and finally if dp of I minus 1 j is 1, or dp of I minus 1 and j minus current element. If any of these two is true, then dp of ij would be true. I have explained already this in the previous lecture. Otherwise dp of ij would be false. So this is the whole subset sum algorithm. So after that, simply if dp of I m is 1, which means we are able to create a we are able to make a subset whose sum is equals to m, and m is half of the sum. So if we are able to make some, sorry, not m, it's n, sorry, not I but n. So we are able to make a subset whose sum is equals to half of the total sum. If that's true, then we would return true. Otherwise we would return false. So let's run and see how many errors do we get. Okay, so here we have one, line number 19, I guess. Yeah, oh sorry, I okay, this is returning false. The expected one is true. This should not happen. Okay, so n is equals to size of the array, then sum is equals to 0 for each element. We are adding, oh sorry, do not know what I do. So if sum modulo 2 is equals to 1, which means the sum is odd. Now what? M is out of bound. So this is what happened when I try to solve problem. These many attempts I have to make. I'm not very good with writing code. So okay, at least the sample test cases are passing. Oh, come on. Runtime error. Index 51 out of bound for type in this one. 37 27 37 28 37 28 this. Okay, ij less than equals to element. We are directly copying the value and says for m plus 1 this is out of bound. Okay, yeah, the problem is the current element. Since you want to make the total sum half, right? There are element like 15 and 5 say, so the total sum is going to be 20. So we are trying to make the sum as 10 because half of that sum is 10, but there is also an element which is 15 itself, so this can be more than half. See, m is actually only 10 while this element is 15 itself. So if the current element is greater than the total sum, then we have to continue. Oh, fish, that happens. Oh yeah, so the problem is happening because of this element can be greater than m. The reason, see, suppose there are two elements in the array, only 5 and 15. So the half of that total sum would be 10. So m would be 10. So the indices which are available to us are from 0 to 10 only, but this element itself is 15. So I'm trying to exit the 15th index which is not available. That is why it is going out of bound. So we have to run a loop till minimum of either till element or minimum of either element or m plus 1. So if element is like 15, the j would still run till less than m plus 1. We have to do it here as well, and here we are going to, yeah, this should work. Only this place can go out of bound. Yeah, as you can see, we are getting the correct answer because only this place which could go out of bound, because here we are running the loop till m only, but here we were running loop till element which can be greater than the half, which I didn't thought earlier. So there is a problem which was happening, and now since we have removed that error, so we get an AC. So this was all for this problem. As you see, how we can use subset sum problem to solve this. So this was all for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.